All right, so our next intermolecular force are dipole-dipole forces. So dipole-dipole forces in general are stronger than LDFs. And dipole-dipole forces, as the name indicates, happen between polar molecules that have a dipole. So, for example, if we have a molecule of HCl, we can draw a dipole here, right? The hydrogen is partially positive, the chloride is partially negative. And remember, a big theory of chemistry is that opposites attract. So if we had another molecule of HCl, the positive would be attracted to the negative and vice versa, right? So if we had another molecule of HCl, it would pack in some kind of structure like this, right? And the reasoning being that you have this attraction between the partially positive and the partially negative components of the molecule, and opposites attract. And so this is what's known as a dipole-dipole intermolecular force. So just some more kind of pictures for you. On the left here, we have the kind of Lewis structure for acetone. So what you want to focus on here is this central area where we have this carbon doubly bound to this oxygen, and we're going to have a dipole in this area. And so you can see that in the electrostatic potential map, right? We have most of our electrons concentrated on this region and not down here with the carbons. And since opposites attract, this negative region is going to be attracted to the positive region of a neighboring molecule, and so they'll pack to maximize these intermolecular forces. And of course, the more intermolecular or stronger intermolecular forces you have, the higher boiling point or melting point that you are going to experience. So that's what this picture shows right here. So you can see as we go kind of left to right, our molar masses stay approximately the same, or in this case of acetonitrile, it actually even gets smaller, yet our boiling points are increasing further and further. And that's due to the polarity of the molecule. Propane by itself is nonpolar, whereas acetonitrile, CH3CN, is very polar. So as we increase the amount of polarity, we get a higher boiling point. This also explains why like dissolves like. Right? If you put oil in water, they will not mix. That's because oil is nonpolar and water is very polar. And so the polar water is attracted to other polar water. And so they're going to pack together to maximize these intermolecular forces and thus disinclude the oil. So polar attracted to each other. And that's what this picture here shows you. Right, they're mixing some of this C5H12, which is very nonpolar, with some water, which is very polar, and the two are not mixing. Right, you can see the separation in between the two layers, right? So down here you've got water, and then up here you've got your oil, and they're not going to mix with one another due to their differences in polarity.